All right, so this is our plate tectonic notes. So if you haven't already, go to Classroom and you want to go to classwork here. It's going to be in our Unit 6 Evolution, and here's your plate tectonic notes, and open up your copy of your Google Docs. Make sure to add highlights and a 3 to 5 sentence summary before submitting, and then create a link on page 64 of your notebook. Okay? All right, so let's go ahead and get started. All right, so plate tectonics, we're going to learn a lot about it. It's really about things moving and how our Earth has moved around. And one of the big things is we'll learn how the San Andreas Fault here in California was actually created. All right, so let's get started. Our essential question is, what is the theory of plate tectonics, and what are the 3 types of plate boundaries? Okay, so what are plates in the first place? So we have different levels of our Earth. So we have what we call the crust, which is not on here, but it's the crust, which is what we stand on. And then we have the center here, which is the mantle. Okay, and then we have the metallic liquid outer core, and then the solid inner core. And the mantle is the stuff you guys are familiar with called lava. And so the lithosphere, as it says, makes up the crust and the mantle. Okay, and everything on the crust is broken up into what we call plates. And plates move around on top of that mantle or lava, just like rafts. So it just kind of moves and they flow based on how the lava and the heat move underneath the Earth. Okay, and then a section of the lithosphere that slowly moves over the asthenosphere, which is down here, which is talking about more the center, carrying pieces of the continental and oceanic crust. And we'll talk more about that throughout these notes. All right, so what is the theory of plate tectonics? It is the theory that pieces of Earth's lithosphere, or crust and mantle, are in constant motion, driven by convection currents in the mantle. So convection currents just means how it gets hot and cold, and those cause things to move around. And you'll learn more about that in chemistry. And plates move slowly in different directions. So even all these continents are still moving in different directions. And they can cause different geological events like earthquakes and volcanoes. So what makes the plates move? And that is a convection current that is underneath the crust, which we stand on. And so you get hot and cold, and as they move and they change, the plates move back and forth, so they can get farther away or they can get closer apart. It's elastic. It's really like almost like you're stretching a rubber band and then letting it go, and stretching a rubber band and kind of letting it go. They can move back and forth. Okay. So the parts that you might be familiar with is, here we have our continental crust, which is the crust, that is the stuff we stand on. And then we have what we call the oceanic crust, which is underneath the ocean. And we could have some stratovolcanoes, we can have some shield volcanoes, different types of volcanoes underneath the ocean. And then right underneath, that is our lithosphere. So that is the mantle, and then we have the asthenosphere. Okay, so some of these you'll have to know the names, but we're going to talk much more about the different plates. Okay, so plate boundaries is the edges of Earth's plate meet at plate boundaries. And you can see here that at one time in our Earth, we can actually put all the continents together like a big puzzle, because they all were one continent at one time, and it was called Pangea. And what happened was, as the mantle heated and cooled, the plates started moving, and so they moved apart. And how do we know that at one time this was all one big continent? Well, that's because, remember we talked about fossils? Fossils were kind of a proof of evolution for some animals. We find fossils of animals on continents where those animals never have lived. And so these continents must have been close enough for those animals to cross over and be there at one time. And so these plates actually extend deep into the lithosphere, so down through the ocean to that center mantle down below. And a fault is a break in the Earth's crust where rocks have slipped past each other. And we'll talk about 3 different places where that can happen. And there are 3 types of what we call plate boundaries, of different types of plates, okay? And so what are the three types of boundaries? And a different type of plate movement occurs along each type of boundary, and we'll talk about each of those. The first ones we're going to talk about is divergent boundaries. And so divergent means to move apart, to diverge. And then we'll talk about convergent boundaries, where those plates move together, they converge, they come together. And then where they transform, okay? All right. So first we're going to talk about divergent boundaries. This is a plate boundary where two plates actually move away from each other. So they come up, and this is when we're talking about when we're just talking about the type of the fissure volcano, when we're talking about these rock pocket mouse. This is a type where that would happen. And so those plates actually move apart, and up comes that mantle, that hot mantle or lava, and that's where we see it. And so this is where we actually get the sea spreading. So this is what happened with Pangea in the beginning. So Pangea, these plates they were all at divergent boundaries, and they started moving apart, and they still are. And that's how we get our oceans, okay? And so what happens at a divergent boundary? It's a geologic feature or event and may form rift valleys. You may have heard of those on continents. So you might have these big dips actually in the middle of a continent where actually these plates have moved away from each other. And we see it a lot in the sea floor spreading. So we can see it under the ocean as well, okay? And so helpful hints to kind of remember this is divergent is like dissecting or dividing. It kind of sounds like that. And so that's what this does. They dissect or they divide from each other. They diverge. They move away. Just like if you think about if you pull warm bubble gum or silly putty till it's really thin in the middle until it's stressed so much that it breaks. And that can happen. At a divergent boundary is we can stretch it so thin that it breaks, and that's when we get our magma or our the mantle coming up. I have to think about that. Happens on land and underwater. And so this is where we're talking about our fissure volcano, right? And so features of divergent boundaries is we get mid-ocean ridges, we get rift valleys, and then like I just said, we get those fissure volcanoes, that was one of the things that the rock could have happened at the rock pocket mouse, okay? So how is a rock pushed at a convergent boundary? So a plate boundary where two plates move towards each other. Okay, so we're going to talk about convergent. And convergent means that they converge, they come together. So how do they get pushed toward each other? And these are boundaries between two plates that are colliding. So we just talked about divergent, where they move away and we get that split and it can get really thin, and that's when we get that fissure volcano. How about when they actually collide or hit, like two big things, boom, like two cars hitting front end to front end, okay? This stress is what we call compression, so you can think they compress against each other, okay? And so at convergent boundaries, these are places where plates crash or crunch together or subduct, and then one actually sinks under the other. So this has happened at the South American plate. So our oceanic crust has come in, it's hit the continental crust, and now it's sinking underneath, okay? And so we see that a lot at the beginning of trenches. You can see it can make a trench. Here it made the Peru-Chile trench. Here we had it do it on land, and it made right underneath the Himalayas. So it can happen underwater. It can happen on land as well. There are three types of convergent boundaries. The first type is an ocean plate colliding with a less dense continental plate. So our ocean plates are definitely more dense than our continental plates, okay? And so, or we could have a subduction zone where the process by which an oceanic crust sinks beneath a deep ocean trench and back into the mantle at a convergent plate boundary, okay? So this is an example of type 1, okay? So here's our continental crust. Our oceanic crust has dipped down, boom, and down it goes. I also forgot to mention, you know how we talked about the oceanic crust when we diverge, we make more oceanic crust. And so that's, you have to remember, our oceanic crust is our younger crust, okay? So it's not as old as the stuff that's up here, what we walk on. It's been here for a really long time. The oceanic crust is made from when those split apart and we get new oceanic crust, okay? All right, so what else happens at a convergent boundary? Okay, volcanoes occur at subduction zones. So what happens is, here we go, here's our ocean plate. Now it's actually, it's down into our mantle, causing a lot of problems down in there, and then it causes that to be pushed out of the volcano. So this is what happens when we actually get a volcano and when they are active, okay? And so it actually happens that this crust sinks down and pushes some of that mantle. It takes up the space, pushes some of that mantle up and through the volcano. Okay, and one of the things we see here is the Andes Mountains, and we get a lot of mountains at this point too in South America. The type 2 is an ocean plate colliding with another ocean plate. Okay, and so when that happens, the less dense plate slides under the more dense. So whichever one, you notice this one is this one out here in the more in the ocean is less dense, and so it slides underneath there because we've got our older crust, which is our continental crust over here, okay? And plates calling a subduction zone, and that's when we get those big ocean trenches, okay? All right, and one of the examples is Aleutian Islands in Alaska. We have a really big trench that has formed out there in the ocean. The third type is a continental plate colliding with another continental plate, okay? So we got two of them hitting each other, bam, and they have a collision zone, a place where folded and thrust faulted mountains form. So that's where we get our mountains. So when two continental crusts actually hit each other, remember these are our older ones, that's where we get our mountains coming up, okay? And they may form mountain ranges, and these are folded mountains like the Himalayas or the Rockies, and those are some of our biggest mountain ranges that we have, and that is from two continental crusts actually hitting each other. All right, what happens when the rock is squeezed from the stress of compression? So if they're moving or they're going convergent boundaries, they're converging with each other, moving. What happens when they boom hit each other and they compress and they push against each other? We get what we call a reverse fault, and a rock is formed upward as it squeezes, and that's how we get our mountains. Okay. All right, so some helpful hints, and remember this, convergent is like connecting boundaries. So they hit, and they may work like a trash compactor smashing a rock. So rock goes crunched up to make folded mountains, and rock goes under at a subduction zone. So think of a submarine. It goes under the water, right? And so a subduction zone is when it gets sucked down, and that's when we can see some mountains. All right, last one is our transform boundaries. And this is a plate boundary where two plates move past each other in opposite directions. And we're very familiar with this here in California. So now instead of hitting each other or moving away from each other, now we're having them just go back and forth like cars, right? And so we want to make sure that we have, how is the rock broken at transform boundaries? So rock is pushed in two opposite directions or sideways, but no rock is lost. So they kind of slide back and forth with each other. And this stress is called shearing. So as they slide back and forth with each other, like if you rub two rocks together, eventually they just start wearing each other away. Okay. And so what happens at transform boundaries? This may cause earthquakes when the rock snaps from the pressure. And the most famous one is a famous fault at a transform boundary is the San Andreas. So we have two plates that run here in California, and they slide constantly against each other. And so when the rock actually snaps, because it's so much pressure as they slide back and forth, guess what? That's where we get our San Andreas fault. And there's a picture of it right there where we can actually see the division of those two plates moving back and forth. Okay. And so what happens when the rock is sheared or cut from the stress of shearing? It's what we call a strike-slip fault. And so rocks on each side of the fault slip past each other as they break. okay? And so that's when we get a lot of our earthquakes. And so shearing means, if you think about it, shearing means cutting. Shears are like scissors. So transform boundaries run like trains, going past each other in different directions as they shake the ground. So you can think about it. If we build buildings on this fault, one moves up, the other moves down, say bye-bye to the building, and just gets split right down the middle. And that's what's happened in some of our biggest earthquakes, okay? So let's do a little test. Can you match the boundary name correctly with its diagram? So we have A here where they're moving apart. We have B pushing together, and we have C where they're sliding. So I'll give you a minute to try that. All right, hopefully you said divergent because they're diverging, they're moving away from A. And B, they're moving towards each other. And in C, they're transforming. So we'll talk a little bit about all three of these as we go through our labs. But I just wanted to kind of give you that background information as I begin to talk about these, okay? So that's the end of our notes. Go ahead and process your notes, highlight any important notes, make connections to any of your notes in the left-hand column. Write any questions you may have in the left-hand column. Use your highlights, connections, and questions for your summary, and then write a 3 to 5 sentence summary. If you have any questions, please let me know.